kids, this is a little lesson that we're kind of interspersing here. Triangle exterior angle theorem. This is kind of cool. So angle 1 is considered an exterior angle of the triangle. All right. I mean, clearly it's on the outside of the triangle. Let me see if I can get this thing to skip. There we go. And when you talk about exterior of a triangle, you're only talking about one per vertex. So, like I could extend this, and this would be an exterior angle. I could extend this, that would be an exterior angle. Or I could extend that, and that would be an exterior angle. Or I could extend this, that would be an exterior angle. You see? We're only talking about one per vertex. An exterior angle is supplementary and adjacent to an interior angle of the triangle. So check this out. Using the diagram, how does angle 1 relate to angles 3 and 4? Well, you know that angle 1 plus angle 2 is supplementary, so they add up to 180. You also know that angles 3 plus 4 plus 2 have to add up to 180 because you know that all the angles of a triangle have to add up to 180, right? Okay. Check this out. If 1 plus 2 is 180 and 3 plus 4 plus 2 equals 180, that means angle 3 plus angle 4 must be equal to angle 1, right? So this is the theorem. An exterior angle of the triangle is equal to the sum of the triangle's remote interior angles. So obviously if 1 is exterior, you see how 2 is not remote. It's right next to it. It's adjacent. Remote means far away. These are the remote ones. All right. So this angle 1 is going to equal the sum of 3 and 4. If we would extend this, like, okay, if I call this x, that angle x is exterior. Angle x is going to equal the sum of 4 and 2, because that's the sum of the remote interior angles. And you could do the same thing, down here. Now, this is not really something you're going to use in a proof. This is more something you're going to do in an algebraic type problem, but that's the main idea of this lesson here. Exterior angle of a triangle is equal to the sum of the angle's remote interiors. So let's take a look at this. You go by the tick marks. It says determine all the angle measures in the diagram. And again, we talked about this a couple weeks ago or so. This just comes with practice. You have to introduce a variable x. And most of these you can do with one variable. Sometimes you might have to introduce a second one. Use pencils so you can erase. So if you decide to start over again, you can. You're typically going to start in some kind of corner. Now watch this. I'm going to call this x. Now I'm looking at the tick marks. It doesn't look at all like it, but look at this double tick mark and that double tick. That means this lower triangle is isosceles. So if I call this x, this must be x. Base angles are congruent. All right, now this is where the magic happens with the new thing. This lower triangle, you see this angle here is exterior to this lower triangle. So it's got to equal the sum of the remote interiors. So this angle must be 2x. And this little triangle up here is isosceles as well. If that's a base angle, that's another base angle of 2x. And remember, look at these tick marks out here. Single tick, single tick. This whole triangle is isosceles. So if that base angle is 2x, this base angle must be 2x. So if that part's x, this is x. So now looking at the whole triangle, we have 2x plus 2x. We have 5x equals 180. You get x equals 36, and you could fill in all the blanks of all the angles in the diagram now. All right. So it's kind of cool. Again, usually you can do this with just one variable. Now here you got a number, So with that 105, we know that's 75. This is isosceles. We know that's 75. But that's about, well, this is 30, of course. Okay. Now, remember, though, you can usually do these with 1. You're kind of stuck there, so you're going to have to call something x. Usually, you're going to start in some corner, okay? I'm going to call this x here. Now, if this is x, look at this. This triangle's isosceles. That's x. All right. Okay. Now, if this is x and that's x, whoops, this angle is exterior to this triangle. Whoops. So this must be 2x. Okay. And then this triangle is isosceles, so this must be 2x. So I think you have enough information here now, right? You know that, of course, you know that all of the angles in the triangle add up to 180. So x plus 2x is 3x plus 30 plus 75 equals 180. So you could solve for x now with that. I want to show you something cool, though, because this is something that students don't see, and you're going to need this in some problems for sure. Check this out. Let's look at this triangle right here. Okay. Remember, this angle here, this 75-degree angle, is exterior to this green triangle. So that 75 has to equal x plus 2x. And then, of course, you can determine all the angles once you have that. So I know you didn't have to use that green triangle to do this particular problem, but keep that in mind. That is really handy. So I'd like you to try the next one yourself. I will tell you the next one, the top one in the back, you will get a fractional answer. So don't let that freak you out. Okay. You will get a fractional answer for that one, but you can do it with just one variable. I would recommend you stop here and pause and give it a try yourself. Okay. All right. Here I'm going to continue now. So AB, this whole triangle is isosceles. AE is congruent to DE, is congruent to DB, is congruent to BC. I'm going to call this X. Triangle's isosceles. That's X. This is exterior to this triangle, so that has to be the sum of the remotes. That's 2x. Hey, this triangle is isosceles too. So if that base angle is 2x, so is this. Okay, now you can get a little stuck. But remember, if you use that idea that we just mentioned, that I just mentioned a moment ago, look at this triangle here. This angle here is is exterior to that green triangle. So it's got to equal the sum of the remote interior angles. 2x plus x is 3x. This little triangle is isosceles, so that's 3x. This big triangle is isosceles, so this base angle is 3x. This base angle must be 3x. So if that's 2x, that's x. We have 3x plus 3x plus x. We have 7x equals 180 from triangle ABC. So x, it comes out to 25 and 5/7. Okay, that's the measure of angle A, because that's what we called x to begin with. So these can be pretty neat. They can be tough too, okay? And, this stuff here, these next two problems, or three problems, these can be challenging. And, angle E, watch this here. Angle E is 70 degrees. JH bisects this exterior angle. So instead of putting tick marks here, I'm just going to call this X and X. And FH, you can try this yourself if you want, bisects this. I'm going to call this Y and Y. So I actually did put a second variable in for this one, okay? But if you want to stop and try to figure out angle H on your own here, that'd be cool. But this is not an easy one for sure. But check this out. If angle E equals 70, then angle EJF plus angle EFJ has to be 110, right? Because we know that the sum of the angles of a triangle is 180. So that's 70. I don't know which these two angles are themselves, but I know they have to add up to 110. Okay? Now this is cool. Watch this. So this plus this is 110. Now watch this. Here we got a straight angle, right? We know a straight angle is 180. Here we have another straight angle. We know that's 180. So if we add these two straight angles together, that would be 360. So watch this. 2x plus 2y plus these two angles. Now remember, these two angles add to 110. That all has to equal 360, right? Because that's a straight angle, and so is this. Watch what happens here. 2x plus 2y, move the 110 over, you get 125. Sorry, you get 250. I'm getting ahead of myself. And then if I divide everything by 2, I actually don't have information. I don't think I have enough information to solve for x or y, but I know that their sum is 125. Now, if this plus this is 125, doesn't this angle have to be 55? Because 125 plus 55 is 180. That's a cool problem. So your homework is to try to do these last two problems, okay, or your assignment. Number 5 is to do the same exact thing as we did up top in number 4. But it says you're going to find angle H in terms of angle E. In other words, instead of being given that this is 70 degrees, just call this angle E. And you're going to develop a formula, use this same idea, but instead of saying that's 70, just call it angle E. You're going to get a formula for angle H. Give it a try. It's not the easiest thing in the world, okay? All right? Not the easiest thing, but I want you to try it. And then on that's what you're doing in number 5. And then on number 6, you have to algebraically try to show that. I want you to try to show that there's not going to be a submission for this homework, okay? But I think you trying these two problems is very helpful, and it might help your understanding with some of this stuff. And this stuff's going to come up, here and there during the year. So give that a shot. We'll talk about it in class, but obviously it's not going to make much sense if you don't try to think about it first yourself. Okay? See ya.